So today I start with fuzzy logic. In crisp sets, only we keep the decision in 0 and 1 form. Suppose that someone asks what is the color of this ball is red or red not, then we will answer yes or no. So this is the crisp decision. However, uh, suppose that someone asks that this student is poor or intelligent, so someone may say that not so intelligent and not so poor. So this is the fuzzy reasoning, and perfectly we don't assign any particular fixed value for that, but the value varies between certain ranges, and these ranges are called the membership. uh, these ranges perfection is given the membership grade. So this is the suppose this is example of the glass, and it may be full, almost full, or empty. This type of wordings this is the fuzzy reasoning space. And so we define the fuzzy set. Fuzzy set x is the subset of x subset uh, fuzzy set A in X is characterized by a membership function mu ax. So suppose that we have different values of x that varies in crisp values. Suppose that 15, 45, 60 and 120 degree temperature, then these x will have different values, and x is subset of x is that set. Okay, so the suppose mu ax equal to 1 will represent that the decision is 100%, and mu ax equal to 0 means decision depends upon that value with the 0 relation, means the membership grade of x equal to 0 represent that the decision doesn't depend upon that value of x. So here we can see that here a graph is given, fuzzy set x1, x2, x3, x4, and different membership grades are at point at x1 0.5, and x2 it is 1, and at x3 it is 0.75, and it is at x4 it is 0.5. The value may be defined by value of a is defined by mu a x1 plus x1 plus mu a x2 on x2 plus, this is not the ratio, but this is the representation, mu a xn upon xn. N is the number of the different crisp values in the set x. So here suppose that so here we have this value. Suppose that x1, x2, x3 are 4 values, input values, and 0.4 of membership grade, 1.0, 0.7 and 0.8 are different membership grades of corresponding input values. Then this 0.4 upon x1 plus 1.0 upon x2, 0.7 on x3 plus 0.7 upon x4. This is the membership function defined by this. And suppose that some other one of the there are two membership functions, one is b1 and another is b2. Then for b1, here suppose that we have two membership functions b1 and b2. then at x1 there is the membership grade of 0.5, at x2 the membership grade of 1, and at x3, because we are considering only the membership function b1, so at x3 b1 equal to 0.4, so 0.4 upon x3 and 0 upon x4. Next, if we consider the membership function b2, then in that condition the x2 upon 0 upon x2, 0.6 upon x3 and 0.9 upon x4. This is 0 upon x1 also will be there, so two elements with 0 numerator, and two elements with 0.6 and 9. So here we can it has been defined the two membership functions. So here I illustrate you how the practically the things are implemented. Suppose that in control system we have the error and the derivative of error. Suppose that error is very high, then I give an example that error is very high and duty cycle is very low. Error is high, duty cycle is low. Medium, error is medium, then duty cycle is medium. Error is low, then duty cycle is high. Error is very low and duty cycle is very high. So this type of decision may be needed in the control system, real-time control system, and so the fuzzy controllers are very useful. Suppose we have this input range of 60. How we determine the range of fuzzy membership grades? So suppose that we have the range of 60 and we have the centers of the ranges, that is centers of the ranges here. Suppose that peak points of membership grades are occur at 0, 15. In center of the cluster, center of the decision space occurs at this 15, 30, 45, 60, and 60 and 85, 75, and this 90. Suppose this is this, and the corresponding centers of this range, this is very low, this is the center of this is this low, center of this is medium, center of this is high, center of this is very high, and suppose this is only the range. I think this is sufficient to illustrate. So suppose this is the range of 0 to 75 and 0 to the whole range is very high. Then suppose that the decision space is such that it should always be overlapping. So this is the center of the decision space. Center of the decision space is this. Center of decision space second, third, 4 and 5. So input range varies from this to this, Okay, so this is input space ये this L, and this is very low, and this is center of low. This center is medium, we take this first is center of this, and this varies from 0 to 30, and this is the whole range of very low. Okay, so this is first fuzzy space, fuzzy cluster 15 to 45. This is second fuzzy cluster. So second fuzzy cluster has center of this, third fuzzy cluster has center of medium. This is the center, this is the center of this. So to enclose this as center, we have this rectangular block, and next is here this is the center for the high membership function. So the range is taken here, okay, and this is the this membership function range, and the last is the fuzzy space, this, because only 75 range is covered. So this is the range of 75. So now we project here for the membership function this. Okay, so we have the first membership function which varies here, and it has the center here and this variation here. Second has the center of 30 and the range from here, which is called the low. So this is VL, and next is the with center 30, that is low. Third is medium, it has center here and it has center this, and the ranges are this is A, and fourth is this center, and fifth is this. Okay, so different membership functions are here, and another membership function with 0 at maximum at 0, that is called ultra low, may be defined, and it has center this, then this is the another membership function. So this is called this ultra low, this is ultra low and high, and this has the center of, this is medium, high, very high. So you can project any input and input into the range of the input output space, and then by this you can define the fuzzy membership functions. So next you have this we have told you how to define the fuzzy membership functions according to the some input. Now you consider that someone takes the value of 62 sorry this is value of 67.5. So 67.5 is in between these, and this is called the between the very low and high. So it will be called 0.5 of very high and 0.5 of high. That means not very high, not high. This is called between this is also called between very high and high. Okay, so now you have any value of any membership. Triangular membership can be defined by three elements 40, 60 and 20. Suppose that A is defined by, then this black color triangular membership function A equal to 40, B equal to 60, C equal to 120, and when the peak point occurs at B, so always 3 points are determined here. First and second last defines the zero crossings, and middle one defines the peak point of this membership function. Similarly, other suppose that other membership function is 60, 120, 180. It is defined by, then the 60 will represent where it crosses 0, 120 degree will define where it has membership grade of 1, and 180 will define the where it crosses again 0. So it may be any value 40 kilometer, 60 kilometer, 120 kilometer, degree centigrade, and RPM, anything, any value it may be. So here this is membership grade equal to 1, and so all any members triangular membership can be defined by three terms A, B and C, where the middle term will represent the peak point. So here we have taken the how we represent the membership functions. To represent the membership functions, suppose that x1 equal to 15, x2 equal to 30, x3 equal to 40, x4 equal to 60, where the x1 x2 are the subset of this input space, and this 15, 30, 40 this is represented. So membership functions are always defined by membership grade divided by membership grade here, and value of the that individual membership grade. Suppose that 15 membership grade of 0.5 is defined, and then this is 15, and 0.5 upon 15, 0.75 upon 30, 1 upon 40, 0.25 upon 60. Here the 0.5 is defined for 15, 0.75 for 30, 1 for 40, and 0.25 for 60. So a complete membership function can be defined by this expression, while we have given the input and the membership grade ranges. Okay, so here how the things are going on. Suppose that we have the four membership functions called the very low, low, medium and high. So if we define that our output is 0.4% of 0.4 of VL, 0.6 of L, 0 of M and 0 of H. That will represent that the point is the input is lying somewhere here, at that is 45 point. This will be um, 40 40% of the VL and 60% of low. So at this point, suppose that we have increased the value at 80, then so this is suppose 100, and this is comes to between, this is 80, so 80 will come here something, so it is the 80%. This is 0.6 of 6 m, and some other membership function is after this. So this will define 80 will define here the 0.6 of m and 0.4 of h. Suppose that this is h. Okay, so 80 is between the medium and high, and 100-degree temperature is full high. Okay, so we can define an input range in terms of membership grades. Okay, now the triangle membership function. In the triangular membership function, we have three values a, b and c, and input may vary, and when input is equal to b, then membership grade equal to 1. So it is defined by x minus a upon b minus a. Similarly, if input x is out of greater than b, then this value will be validated. Then for b value of b, c minus b upon c minus b equal to 1. And if suppose that x is greater than b, then this value will be greater than 1. So in that case, we will consider only the membership grades which are less than 1 and exclude the greater than 1 values. So to retain always the decision boundary between this area. So this minimum of x minus a upon b minus a, c minus x upon c minus b is taken. Now suppose after taking this decision minimum, we have 0.001 and 1, so it must always be greater. So the maximum value is taken. So always the membership grade is taken greater than 0. So the membership function is always defined between this area, and out of this area where 0 crossings, after 0 crossings, this is not considered. Okay, so this is all about the fuzzy and fuzzy membership functions. Later we will discuss the types of membership functions.